Mitigating stormwater runoff, a comprehensive approach. Much of the United States has seen an increase in total annual precipitation over the last 120 years. And since 1901, rainfall in the U.S. has increased 0.2 of 1 inch per decade. Since 1960, there has been an increase in the number of extreme one-day precipitation events. These extreme events lead to local flooding, overwhelm sewer systems, which also overwhelms water treatment plants. They generate stormwater runoff that affect local waterways, which damages the local waterways. As towns grew into cities in the 19th and 20th century, prime land was plowed over, wetlands were drained, and streets were paved. All this led to less infiltration and more runoff. The extreme precipitation, single-day rainfall events are causing more localized flooding and also greater amounts of stormwater runoff. It's this stormwater runoff that we're trying to prevent. In 2019, Congress enacted the Water Infrastructure Improvement Act, which defines green infrastructure as the range of measures that use plant or soil systems, permeable pavement or other permeable surfaces or substrates, stormwater harvest and reuse, or landscaping to store, infiltrate, or evapotranspirate stormwater and reduce flows to sewer systems or to surface waters. Taking a look at this quick illustration here, we have what's called a combined sewer system, much like we have in Chicago. So you can see on the left, the toilet and the sink drain into the sewer, but also the roof drain and the storm drain flows into that sewer. So during heavy rain events, that sewer will become completely full of water, which could lead to backups into your home or combined sewer overflow into waterways, completely inundating the water treatment plant. If too much stormwater runoff enters the sewer system too quickly, the sewers begin to back up into homes, businesses, and can sometimes even create sewer geysers because of all that back pressure from all the water entering the system. Green infrastructure attempts to divert as much stormwater as possible from entering the system, or at least detaining it as long as possible. Now, green infrastructure works at so many different levels. It works at the homeowner level, where you can implement small things at home. It also works at the community level or the neighborhood level. Here in this picture, we have permeable pavers, we have trees that are planted, so on and so forth. And finally, green infrastructure projects at the largest level, the infrastructure level. This example here is in Buffalo Grove. Now, green infrastructure you can start implementing at home, such as disconnecting your downspouts. You can actually harvest rainwater as well. And finally, you can install rain gardens to collect some of that rainwater. So disconnected downspouts, for example, when over 1 inch of rain falls on a 1,000 square foot roof, over 630 gallons of water will go right down the downspout into the sewer system. By disconnecting and diverting downspouts away from sewers, the rainwater can infiltrate back into the ground where it recharges groundwater supplies. Up next is rainwater harvesting. So rainwater can be diverted and captured in rain barrels or cisterns so that homeowners may use the water for irrigation. Typical suburban lawns require an additional 10,000 gallons of water per year up and above rainfall. So this is where rainwater harvesting can really start to help. And rain barrels capture approximately 1,300 gallons of water per year. Finally on the list is rain gardens. Rain gardens are small, shallow, sunken areas of plantings that collect stormwater runoff from roofs, streets, and sidewalks. Also known as bioretention cells, they are designed to mimic the natural ways water flows over and absorbs into land to reduce stormwater pollution. Next up are bioswales. Bioswales are essentially rain gardens placed in long, narrow spaces, such as space between the sidewalk and the curb, Typically, you'll see these in larger parking lots. And oftentimes, like in the front of the picture, you will see that there is no curb in the front so that water can directly flow into the bioswale itself rather than heading towards storm sewers. Next, permeable pavers and porous pavement. This here is an example in an alley. Permeable pavements infiltrate, treat, and or store rainwater where it falls. They can be made of pervious concrete, porous asphalt, or permeable interlocking pavers. This project here is on the northwest side of the city. This was done by the Metropolitan Water Reclamation District. It's a combination of permeable pavers in the middle and then porous concrete on the outside. And this alley is one of 7 they did so far this year, and this can detain up to 100,000 gallons of water that is not entering the sewers. So back in 2010 and 11, a section of Cermak Avenue between Ashland and Halsted was actually dubbed Chicago's Green Mile. Here, this was a pretty forgotten industrial corridor, had heavy rail traffic on the right-hand side, industrial traffic going down the street. What they did was they created bioswales. They installed permeable pavers, rain gardens. They planted lots and lots of trees, native plants and things like that. Here is a section of Benito Juarez High School, which again has bioswales, rain gardens, permeable pavers. All the downspouts are disconnected and actually feed into the bioswale. There are small little bridges over the bioswales and things like that. So when the water is flowing heavily, it's almost like a creek. Their goal at the high school was to eliminate all stormwater runoff. One of the final ways that green infrastructure can be implemented on buildings is with green roofs. Green roofs actually capture and detain 30 to 90% of rainwater during smaller rain events. Chicago is actually leading the way with 509 green roofs within the city of Chicago for a total of over 5 million square feet. McCormick Place actually grows about 8,000 pounds of produce on top of their green roof that supplies their restaurants. My building, for example, has 2 green roofs. My lower green roof on the 6th floor here can detain about 5,500 gallons of water for every single inch of rain that falls onto that roof. I also have an upper roof, which is about 4,000 gallons of water. And underneath my parking garage ramp, I have a water detainment tank that holds 25,000 gallons of water. Another way that green infrastructure can be implemented is through education and community engagement. The Metropolitan Water Reclamation District actually started the Calumet Water Reclamation Plant Community Partnership Council, of which I am a member. One of our main goals is to get the community involved, teach them these green infrastructure projects that they can do at home, they can do at the community level. We've also developed an overflow action day alert. So this will let homeowners, businesses, residents know when to not use as much water so they're not inundating the sewer system. So finally, if you can build an army of allies through community engagement, then you have that many more hands to fight the battle against stormwater runoff and overflow. So the more community members you can get involved, the greater your impact will be.